I'm here with Dr. Lucía Cabo and Fernando Rodríguez from TDK, and they have just shown a new capacitor, film capacitor type for wide bandgap devices. So, Lucía, wide bandgap semiconductors present different requirements to passive components, especially with DC link capacitors. What are the special requirements?
Usually, due to the high switching frequencies and the low frequency losses, and the main requirements are the high temperature operation, the miniaturization as well, integration into the system, higher efficiency into dissipate the losses, and also be able to cope with very large DVDTs.
Okay, so generally spoken, in the DC link, mostly aluminum electrolytic capacitors were used for this purpose so far. Which disadvantages have electrolytic capacitors in the DC link?
Well, probably these electrolytic capacitors are really widely used in the low power range of applications, but when you are increasing the power range, both aluminum electrolytics and film capacitors are possible. Normally, it depends on the energy density, or better, the power density, the current density, and the frequency response.
Well, in general, electrolytic capacitor is a very good solution because it's the technology that gives you the maximum energy density. But unfortunately, it has some drawbacks. The first drawback, for example, is that the performance at high frequency, I mean, how to handle the high frequency current is not very good in that sense. And apart, the capacitance depends strongly on the temperature. That is also a drawback. I mean, it's not completely stable. In that sense, for wide bandgap applications, the film capacitor is probably the best solution. First of all, the capacitance is extremely stable with the temperature. And second, in terms of power density, is very good. And you know better than me that normally wide bandgap applications require very high current densities.
So, on the other hand, film capacitors are not known for being thermally very robust. So, what has TDK done to overcome the issue with thermal robustness?
Well, film capacitors, the traditional film capacitors based on polypropylene, is true that they have a limit of around 105 degrees to operate at full power. And to cope with that limitation, we are introducing capacitors based on a different dielectric material, so which is a dielectric blend made of polypropylene and a COC, cycloolefin copolymer.
So, which advantages has this dielectric, or has it also drawbacks in contrast to the normal polypropylene?
Yes, the main advantage is the robustness against temperature. So you can operate with this material to 125 degrees with much less the rating that you could need to apply to polypropylene capacitors. And also they are almost as easy to process as polypropylene. They can be produced in existing state-of-the-art polypropylene lines, which is an advantage. It's not an exotic material which will require something totally new setup. And the main properties of the polypropylene, which is the low tan delta, so the low losses density, and the self-healing abilities are remaining. So this is the main advantage.
So, on the other hand side, the frequency-dependent ESR is also a topic you have addressed with this new concept. So, which design rules have you followed to design the new capacitor?
Well, first of all, the most important design rule has to be that the impedance of all the elements inside the capacitor has to be the same, independent from the frequency. That is the only way to be sure that the current is going to be distributed homogeneously. Second, for the design of these high-frequency capacitors, it is always mandatory to use a finite element analysis software. That is the only way to be sure that you have taken into account all the parasitics from the elements and avoid the problems of the negative electromagnetic interaction between the elements, or else possible resonances or inhomogeneous distribution of currents.
So the new capacitors are now in development. When will we see the first products?
The product is still in development. We are, of course, already supplying samples to some specific customers and semiconductor suppliers in order to have a field experience, but it is expected to have the product completely developed at the end of March 2020.
So, Lucía, Fernando, thank you very much for the interview.
Thanks to you.
Thank you.